Morning. Excited or what? Last class. I don't know if I have some period, but last class for me anyway. For you guys, I have some period, but this is our last time together. Alright, so what we're gonna do? Oh, we'll wait for a minute for people to join. Okay. So I'm gonna talk about how we're gonna organize today's class, and just follow instructions. Okay, you got this. We only have 9 people so far. Do people just ditch class now, or what? The connection's stable too. I wonder what happens. Hi. Alright, looks like people are finally joining. We'll get started then. So today we're gonna split the class into 2 parts. The first part we are going to finish 11.8. Okay, that's gonna be about half an hour, so it's a relatively short thing. And the next half an hour is going to be a Zoom call. I'll send you a link, and we're gonna review with Kahoot. All right, hope you guys will enjoy the last Kahoot we have together. So yeah, make sense? Here we go. So 11.8. Here we go. So we're gonna explore volume and area, surface area. Can't spell. Surface area of spheres. All right. This is going to be the 4th of June. Right, 4th of June. All right. So, what is a sphere? Sphere is essentially like a 3-dimensional circle, right? If you look at it, it has a center, it has a radius, and the only difference is that not only is flat, it also has a depth. So it's the locus of the points are all the points that are equal distance from the center. Okay, so it's like a ball. Okay, and when we cut it in half, that kind of like a circumference circle thing. We call it a great circle. That's the longest circle around, okay? And every time you have a great circle, you cut the sphere into two hemispheres. Hemisphere means half a sphere, okay? So is it good? Now let's explore the volume first. So let's say volume of the sphere is 4/3 pi r cubed. Now, it might seem random. I'll send you a link on all the animation proofs later today on basically how they visualize this, but I'm going to briefly talk about it. So in the video, you will see, or not just video, what we're going to do is that we're interested in the volume of a sphere, right? So let's just do a hemisphere first. We're going to do half a sphere, okay? Then we'll times 2 afterwards. So what we're going to do is we're going to open from here. And then we're going to project, because this is H, right? This H and this R is the same thing, okay? First of all, H and R is the same because this is a sphere. So this is R. So what I'm going to do is I'm going to project or open this up, okay, until it looks like a cylinder. I can do that by projecting it straight onto the wall, okay? And if I project it, since it's a projection, the vertical height does not change. So this height is still R. However, because I open it, so the volume I'm interested in is now just this part. Okay, can you imagine if I cut this and I open it over here? It'll look like that. And because of that, we can now compare the volume. This volume will then be, well, they're the same volume, but this volume to calculate it would be the cylinder, but you have an emptiness in the cone, so subtract the cone. Kind of make sense? That's how it works. How are we doing? And then you calculate the area, the volume of each, right? You subtract, so pi r square h, but the h here is radius, so r, minus, this is 1/3 pi r square h, right? Pi r square h is still r. So essentially, when you subtract it, this is pi r cubed minus 1/3 pi r cubed, so this is together is 2/3 pi r cubed. But this is only half, right? So if you want the whole thing, then you double it. So if you double it, you get this. 4/3 pi r cubed. Okay, this is a brief idea of how you prove it. I'm going to show you the animation later. Not later, but like I'm going to send you the link, okay? So there's that. So let's use it. Look at this. Hi, Ryan. Find the volume of a sphere. Give your answer in pi. I mean, it's pretty simple. You know volume is 4/3 pi r cubed. Your radius is half of this, so it'll be 12, right? So it would just be 4/3 pi 12 cubed, which end up being 2304 pi. They should leave it in pi, right? This is volume, inches cubed. Does that make sense? Can you try the right side? Let me move it slightly over here. Okay, try the right side. Let me know if you find a good answer. Remember you're doing half a sphere. All right, not whole sphere. So it should be 2250, right? If you do it right. So it's gonna be 2/3 because you're only doing half. Instead of 4/3, you're doing 2/3. Pi r cubed, which is going to be 2250 pi inches cubed. If you multiply it out, it'll be 7,000 something. Okay? Alright. Good. That's just applying the formula. Shouldn't be too bad. Alright. Find the radius of a sphere with volume 2304 pi feet cubed. We already did this one kind of, but this is the opposite, right? So normally how you set up is, well, I know a volume of formula is 4/3 pi r cubed, right? But I know the answer is 2304 pi. Then you can solve for r, right? To solve for r, oh sorry, it's meters cubed. Meters cubed. You're right, meters cubed. Thanks, Joseph. So then when you get this, you can cancel out the pi, and to solve for r cubed, you can multiply this over, or divide this over, which is multiplied by the reciprocal. So again, times 3/4. Right? So you're going to end up with 1728. So r is 12, which is in feet because we're length, right? Because it's the same number, it happens to be the same radius as example 1. Okay? Questions so far? Try number, I don't know what number it is. Try the right side. Okay, try this one. Right side. Move it over here. Try the right side. All right. Give you about 2 minutes. I think you're right, Darren. I think you're right. Anybody else get a different answer? Okay, looks like we all got the same answer. Let's make sure that we are on the same page. So the simplest way, or the most straightforward way to do it, is you actually calculate both volumes out. Okay, V1 is 4/3 pi, R is 11, right? Because your diameter is 22 cube, right? So that's that, and then you're gonna get what? If you multiply the whole thing out, you're gonna get like 55, 75 to 8 without the pi, right? You just multiply the whole thing, and then you do the same thing. So 4/3 pi 17 cube, and you're gonna get like 25, 79.25, something like that. And then you divide, right? This divides by that, you're gonna get about 3.69 times. Okay? That's how you would do it in a straightforward way. But let's look at fundamentally what this is happening, okay? So fundamentally, if you look at, you're gonna be looking at how these things change, right? So the thing that are changed is 4/3 pi changing? No, 4/3 pi stays the same. The thing that's changing is from 11 to 17, right, in the R. So the ratio between them, originally it was 11 to 17, right, in the length. But the volume, because it's R cubed, it's cubed, right? It's three-dimensional change. So your ratio becomes 11 cube versus 17 cube. So you can just divide 17 cube over 11 cube, you'll get the answer. Okay, that's the idea. This is the same thing as you remember when we did similar polygons. If your scale factor is like 1 to 2, then your area ratio is 1 to 4 because it's squared. 2 to 3 becomes 4 to 9. It's the same idea. Okay? Can I get a comfort level from 1 to 10 for first page? This is for volume. Oh, I get a 10s. Whoa. All right, I think most people are comfortable with this. Let's flip it over then. So next page is the surface area. Okay, surface area. So surface area is similar to the proof. It's all more abstract and not abstract, but like it involves some sense of infinity in this. So basically what they did is, okay, I want to find the surface area, which is the area around it. So what I do is I'm gonna cut from the center a bunch of slices. I'm gonna show you the video of this too. Bunch of slices for this. And I'm gonna find the base area, and I'm gonna add all these base together, basically. Okay? And that's the idea. The formula ended up being 4 pi r squared. Once again, I'll send you the video for the animated proof later. Okay? So 4 pi r squared is your formula, so let's just use it then. So you have this. Area is 49 pi miles squared. So what would, because your volume is, not volume, surface area is 4 pi r squared, right? So you need a radius. What is the radius here? Seven. Good point. 7. So you just do it 7 squared, which will end up being what? 196 pi. This is in miles square. Okay. Why is this square again? Because you're doing surface area, right? You don't have to try the right side because we'll just do it together. 50 centimeters. what is the radius? Because once again, for why do I keep putting volume? Surface area is 4 pi r squared, right? So 4 pi, this one will be 50, so 25, right? Half of it, so it'll be 5 squared, 25 squared. So it'll be 2500 pi. Centimeters square. Right, centimeters square. Okay. All right. Last part. I'll give you some time for the last part. There are two things you need to find. This is a composite figure. To find the surface area and volume, or surface area and volume, these things. And while you're here, can you say you're here if you're here, so that I can take attendance? And work on this problem while So Darren has an answer. You guys verify if that's correct or not. He's right? Sure? All right. Take a look. So, volume, right? Volume is going to be, consider the top hemisphere, so it'll be 2/3 pi r cubed. Instead of 4/3, it's 2/3. It's only half. And the cylinder is pi r squared h, right? Base area times height, pi r squared times height. So 2/3 pi r is going to be 6, right? Plus pi 6 squared times 9. So together, this ends up being 144 pi plus 324 pi. Together is 468 pi. This is in inches cubed. Right. So that's volume. Surface area. Notice that because we're doing surface area, the first part, there's no bottom part, right? So you don't have to worry about the base area for this one. So we're going to do the, let me draw the picture first. So this part minus a plus this lateral part without the base. And then finally, we're going to add the base area. Okay, this is my picture. This part, the lateral, not the base, and then the base. Okay, only one base. So, because of that, this is going to be 4 pi r squared, half is 2 pi r squared. This is the circumference times height, so it would be 2 pi r h. This is just pi r squared. Okay, circle. So together, this is a 2 pi r is 6 plus 2 pi 6 times 9 plus pi 6 squared. Okay. So together, 72 pi plus 108 pi plus 36 pi. Altogether, 216 pi inches squared. Okay? Alright. So, hopefully that's good. If you are okay with this, I already sent you a Zoom link through your Loop mail, so you can go ahead and join the Zoom meeting. I will host the Kahoot on Zoom. Okay? So once you're ready, you can join. Okay? See you in a bit. Hello, hello. Welcome. So you can start joining once you're in. I'm gonna close this